functions, we have to be able to look at a graphed set of relations, a graphed relation, and be able to find out, is it a function or not? And it's actually pretty easy. But in order to remind you what in the world a relation is, because it sounds just kind of funny, when you see this pop up in math terms, until you start to get the idea that it's a set of ordered pairs, it kind of seems wordy. And people don't really relate with what a relation is. So a relation is just a set of ordered pairs like these. Here's 4 different points. An ordered pair is an x and y value together that we could put on a graph. So I can literally graph this relation. So it shouldn't be a shocking revelation that this term graphed relation just means points on a graph. Okay, and we're saying, can you look at this graph and see if it is a function? We've got a special tool that we can use called the vertical line test. And basically, if you're looking at a graph, you could swing your pencil right across the page and not have to worry about it. It's not very complicated. Trying to fix the graph there again. There we go. And it's basically this. It's almost like freeze tag. Well, no, we're not going to go that route. Let's back it up and do this. If your pencil bumps into more than one point, it's not a function. So see where it's bumping into these 2 points right here? Not a function. It's okay if it hits 1 point. It's not okay if I hit more than 1 point. So because it hit 2 points right here, that's not okay. Now over here, see where it's hitting 1 point? This part of the relation is fine. And over here where it's hitting this one and it's hitting it all by itself, that's fine. But where it's hitting 2 at the same time, that's not fine. So that's how we use the vertical line test. And we'll talk about how that fits into this definition of what a function is on our next slide after we get through a couple more problems. But let's look at this one. Is this graphed relation, the set of ordered pairs that's been graphed on here, is it a function? Well, that one's only hitting 1 point. This is only hitting 1 point. And that's only hitting 1 point. So we're good. This is a function. Let's go on down and take a look at this one. Ooh, yeah, we're not going to be looking at just dots. We're going to be looking at graphed lines, and some of them are going to have some pretty cool curves in them. But we've got to sit down and take a look at this of, does it pass our vertical line test? Now, just stop and think for a second. In order to flunk a vertical line test, that means that a dot has to be right above another dot. So it's got to be perfectly vertical. That's why we call it a vertical line test. So anything that is kind of slanted, see how like if we connected a line that was slanted like this, we would only be hitting 1 point at a time. If it's slanted, it's got to be perfectly vertical to flunk this test. So ask yourself this, from here to here, let me get a highlighter out. From here, that's not a highlighter. There we go. From here to here, is this line perfectly vertical or is it curving a little bit inward to the top? That's curving, so that's gonna be just fine for this vertical line test. Okay, so from here to here, I have no issues at all. Now, from here on down, let's ask ourselves the following. Is it curving down? Yeah, it is. It's not perfectly vertical. So that means from here to here, my pencil's only going to be hitting 1 point at a time. Now, if we continue this trend, the next question that I have for you is isn't this identical to that? And the question is yeah, each one of those, none of them are vertical. So all 3 yellow zones are fine, and this is the same as what we found here on this pattern. So as a result, all of the aqua, bluish, whatever color this is, zones are also free from this vertical line test. It's only touching 1 point of that function at a time. Excuse me, at 1 point of that relation at a time. And so since it passes this vertical line test, we know it is a function. Well, let's go down and take a look at this one. And I've already got our pencil lined up here. Um, just ask yourself this. How many points is it touching? Well, it touched here, 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 and all the way down. You can see the pattern. It's touched 6 different times, so it flunks. It is not a function. Now, don't get me wrong. This is a relation. Remember, at the very top, we talked about it. When it says uh, it's a graphed relation, that means it's just points on a graph. That's fine. We're just saying, is it a function? Is it a special relation? This one is not. It's just a relation. It's not a function. This is still a relation, and it is a function because it passed our vertical line test. So just remember the basic rules. When you're bringing your pencil across, if it bumps into more than 1 point, it's not a function. If it bumps into just 1 point at a time, it is a function, and you've got to get used to looking at it like this too. You know, if any points of it would be lined up with that vertical line as you waved your pencil over, it flunks. If none of the lines are perfectly vertical and there's not a point that's right above it, like see this point right here, there's nothing above it, nothing below it, we know that this is a function. So we're going to take this knowledge of this vertical line test and we're going to see if we can actually work at a little bit more of a complicated scenario. This one usually causes some people trouble, but we're going to put it in terms that we understand. A function is just a rule that defines each input as having one output. We know this is an x. Well, let me get a pen back here. We know this is an x. We know this is a y. This is an x. This is a y. X and y. So we've got 3 ordered pairs. So it's a relation, a set of ordered pairs. And we're just saying, is it a function? Well, x's other name is input. So if I put this through a special rule, I get an output of 2. If I put in an input of 2, I get an output of 3. Okay? And then this time, I get an input of 1, but I get an output of 4. Well, that causes a little bit of an issue here. When I put a 1 in here, I got a 2. When I put a 1 in over here, I got a 4. That doesn't sound like an input having 1 output. So because 1 has 2 different outputs, and that's what it's talking about, 1 could get us a 2, or 1 could get us a 4. It's got 2 possible outputs here. That's not a function. So let's go and use a graph, and let's graph these 3 points that we have right here. And let's actually see if it makes a function. Now let's see, here's 1, 2, so here's 1, 2. Here's 2, 3. And here's 1, 4. I bump into this point and I'm okay with it, but when I bump into this point, I'm not okay because I hit 2 points, so it's not a function. So let's take this idea and let's take a look at this one. My input is 4 and I get an output of 1. Okay, so for every 4 I'd get a 1. My input's a 3 and my output is a 0. Here my input is a 0, but my output is a 6. Look at your inputs. Did any of my inputs repeat? No? Automatically function. If your inputs do not repeat, it's a function. And let's go graph it to show you. Here is 4, 1. Oops, sorry, 4 1s right here. 3, 0. And here's 0, 6. See how it passes our vertical line test for those 3 points? This relation is a function. Well, let's go and try this one. 4, 2, 3, 2, and 0, 2. Did any of my inputs repeat? No. So it's a function. I don't really care if my outputs start repeating. See that? 2, 2, and 2? That doesn't bug me. What I want to know is did any of my inputs repeat? No. So let's go graph these. Let's see. 4, 2 would be right there. 3, 2 would be right here. And I need to go up to get that third point. 0, 2 is right here. So when the y's all repeat but we have different inputs, it passes that vertical line test as well. And again, here's the basic rule. If none of my inputs repeated, it's a function. I've got two more, but I'm going to have to make the second one. Let's take a look at this one. Did any of my inputs repeat? Well, this 6 got me a 5 for an output, and this 6 got me a 2 for the output. That's an issue for me. That's not a function. I don't care that the y repeated up here, but what I care about is when the x's repeat, it better get me the same output when it does repeat. This 6 got me a 5. This is not a 5. That's why I'm saying it's not a function. And let's go graph these. 6, 5, 6, 2, and let's see, 4, 4. We're fine with the vertical line test here, but when we get over here with the 6, sorry, it should be 6, 5, 6, 5, and the 6, 2, they're stacked right on top of each other like that. And so as a result, it flunks that vertical line test and is not a function at all. And then we do need to take a look at this situation right here. And all we're going to do is I'm going to change this 2 to a 5 because we're going to ask ourselves, did any of our inputs repeat? Well, yeah, the 6's did. This got me a 6, 5, and this got me a 6, 5. Well, it's okay for my inputs to repeat as long as it gets me the same output each time. Because when I go to graph it, you know, there's 6, 5, here's 4, 4, and I go to graph the other 6, 5. It's just the same point, and so it passes that vertical line test. I can't really tell how many times I've graphed it. And it's okay if the dot's literally right on top of each other like this. Now, if they're split and there's one down here, yeah, we've got an issue. Okay, 6, 2 and 6, 5, that's an issue. But 2, 6, 5s like that, how can you tell? You can't. And you're okay. You would say, yeah, this last relation is a function. And it all comes back to this definition. A function is where each input has one output. Whenever my input is 6, I know my output's going to be a 5 every single time for this relationship right here. The problem with this is that my input has more than one output. This 6 could get me a 5 or it could get me a 2, so it's not a function. But here, none of my inputs repeated, so as far as I know, each input has just one output. Every time I put a 4 in, it would still get me a 2. Every time I put a 3 in, it'd get me a 2. But that's the rule, you know. The 3 gets me a 2. I could care less about what this 4 does. If I have a 3 again, it needs to get me a 2 for this scenario to be a function.